Okay, in this video I'd like to do this problem shown. And in this problem it says consider a relation Tn on the set of integers z defined by Tn is those ordered pairs x comma y such that the distance between x and y, that is the absolute value of their difference, is n times a for some integer a, meaning it's a multiple of n. Okay? Is Tn an equivalence relation? Carefully justify your answer. Yes, it is. This is equivalence modulo n. Okay? It's symmetric because of the fact that we can reverse the order of the elements x and y inside of an absolute value sign. That is, x minus y is equal to, I already wrote it, y minus x. So if x comma y is in the relation, so is y comma x. It's reflective because the distance between a number and itself is 0, which is a multiple of n. Okay. It's transitive. This one's a little bit more tricky to show, and I only show it for one of the cases. Let x comma y and y comma z be in the relation. Let's prove that x comma z is in the relation. We're going to go ahead and say that x minus y is a times n and y minus z is b times n for two integers a and b. And now there's a bunch of different cases we have to take into account. The relative positions of x, y, and z. And there are 6 of them. We know that because there are 6 permutations of 3 elements in a set, and so I can put these 3 things in 6 different orders. Okay, 3 factorial. And I'm only going to consider one of them. Let's go ahead and assume that x is less than y is less than z. And then we can write that x minus z is z minus x. Absolute value of x minus z is equal to z minus x. And we also know that that's equal to z minus y plus y minus x. And that's equal to the sum of these 2 absolute values, which is the sum of 2 products like this. And I can factor out the a plus b. And so a plus b is also an integer. And so the difference between x and z is an integer multiple of n. So it's also in Tn. I guess I did one more case here where x is in between y and z, and you can follow the math through here. X minus z is z minus x. Here I did the same trick. I somehow inserted a y in between. I got a minus y here and I got a plus y here once I distribute that minus sign. And I get these 2 guys, write them out as their multiples of n. And again, I have an integer, b minus a, times n. So it is. Okay? And I just say similarly for other cases. You can go through all 6 of them. You might be able to come up with a clever way of combining several of these cases into one. But that's the idea. So it is an equivalence relation. Carefully justify your answer. Write down the equivalence classes of Tn. Oops, I forgot to do that, I guess. Tn, oh boy, we run, and I noticed when I went over this on the board the other day, I've got a problem with notation here because I'm using T, capital T with a subscript n, where the n indicates the n of the modulo function, but I also use T with a subscript n or subscript x or with a subscript to mean the equivalence class of the relation T that contains x. So I guess what I'll do here is I'll say Tn comma k is the equivalence class of Tn it's the equivalence class of k in Tn. in the relation Tn. Okay? And this is equal to dot 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 0, n, 2n, 3n, dot dot dot. Okay. I guess in general 0 is not in the set, so I better write something like, oh yeah, no, that's not correct. Got to think about these things before I write them down. Hold on here. So I'm going to erase this properly. Okay, so in general, this is dot dot dot, and it has the element k in it, but it also has k minus n, k minus 2n, etc., k plus n, k plus 2n, etc. Okay, so that's the equivalence class of k in Tn. It's those, it includes k, and it includes all those guys which are integer distances, multiples of n away from k. Okay, these two guys are n away, these two guys are 2n away, etc. Let's see, what else did I forget to do on part C, maybe? This relation describes one of our number theory topics. Explain. This is equivalence mod n. And that's because the equivalence classes of Tn are the sets of integers that are equivalent to each other, EQ mod n. Okay, so that should finish up this one. I hope that helps. Hope that's clear.